Hello guys. In this video, we will learn about RabbitMQ architecture. How RabbitMQ works. The basic architecture starts with a producer and consumer. Producer is the application or service which is sending messages. Consumer is the application or service which will be receiving the messages sent by producer. Now you will ask, this can be done simply by calling consumer service directly. Why we need message broker? Message broker is required when you don't want to wait for consumer application to execute complete process. You just want to send the message and want the consumer to process in the background. For example, a application where you wants to send some notification mails to all your users about some new updates or features. This can be done in background. Another example, when user uploads some profile picture and you want to compress images and put as display image. This process needs some time to compress image based on size and other factors. So you do not want the user to wait for this complete process. There are a lot of use cases where process can take some time for execution. But to make application faster, you do not want to wait for the process. All these types of complexities can be handled by message broker. In previous demo we just saw a simple application where a producer is using message broker and consumer is reading those messages. First let's see the components in message broker. Message queue, exchange, bindings, exchange types, channel. We will learn all these topics one after another. Let's start with message queue. A message queue acts as a buffer inside message broker which stores the messages which can be consumed by receiver whenever it comes alive. You can set different types of configurations for queue, such as durable, auto-delete, and exclusive. We will learn these as well when we will start demo. Exchange. Any messages which is sent by producer is not directly pushed to queue. Instead, producer always sends messages to an exchange. Exchange acts as a message routing agents, which is defined inside RabbitMQ. It will be responsible for routing the messages to different queues with the help of headers, bindings, and routing keys. Bindings. It is a relationship between exchange and a queue which is used to route the messages. Exchange types. RabbitMQ routes messages to queue based on exchange type and bindings between exchange and queue. For consumer to receive message, it should use at least one exchange. There are 4 types of exchange. Direct exchange, Fanout Exchange, Topic Exchange, Header Exchange. Direct exchange. It delivers messages to queues based on routing keys. The algorithm behind a direct exchange is simpler. A message goes to the queues whose binding key exactly matches the routing key of the message. Fanout Exchange. It routes messages to all queues that are bound to it, and it ignored routing key. Topic Exchange. It routes messages to one or many queues, based on matching between a message routing key, and the pattern that was used to bind a queue, to an exchange. Whenever any problems involves, multiple consumer that selectively choose, which type of messages they wants to receive, the use of topic exchange nages should be considered. Header exchange. A headers exchange is designed for routing on multiple attributes that are more easily expressed as message headers than a routing key. It ignores routing keys. Routing is done based on headers attributes. A message is considered a match if the value of header equals the value specified upon binding. See you in next video, where we will see a demo of what we learned. Thanks for watching.